Okay, so we're going to go to chapter 8. So we just finished chapter 6, but we're going to go to chapter 8. We'll skip over chapter 7. If we have time at the end of the year, we'll do chapter 7.
No.
Okay? Chapter 7 is logarithms and exponents. What?
Can we just do the easy? Yeah.
No, this isn't that bad.
Well, I just need this pass. I just need this first semester to pass.
This is what we're doing right now.
I don't know. I'm like stressing right now.
All right, so
Give me a paper bag.
starting. Quiet. Starting chapter 8, we're simplifying rational expressions. So before we actually go into simplifying, I do just want to do a little bit of review of factoring. Okay, I want you to remember how to factor. So for this first one, you want to find common factors to pull out if you have any common factors. Shh, you guys need to stop talking and you need to listen. Not right now. You're taking notes right now. Okay, you want to find common factors to take out. So with 9x squared minus 81, both of those contain a 9. So I can factor out a 9. So when I do that, I have 9 times x squared minus 9. Shh. All the talking needs to stop. From this point, I can also factor x squared minus 9. Okay? I can factor x squared minus 9 into x plus 3, x minus 3. So when you see this x squared minus a perfect square, okay, it can be factored into a plus and minus of those squares. So if this was x squared minus 16, I could say that's x plus 4, x minus 4. Okay? If it was x squared minus 25, I could factor that into x plus 5 times x minus 5. Okay, it's those perfect squares with the subtraction between that you can factor that. Now if I had x squared plus 9, that's different. You can't factor that one into that plus or minus. Okay? It wouldn't be able to be factored then. X squared plus 9 wouldn't factor. Okay, so that's the first one. That's how I'd factor number 1. Number 2, again, my first step is to find common factors and take them out. Okay, so they have a common factor of c. So when I take c out, I'm left with c minus 6. Okay, and that would be your factored form. Okay, now for number 3, do you guys remember the x method of factoring? I don't remember if you were taught that or not.
Oh, like the box?
Kind of.
Oh, I hate this.
Okay, so you want, yes.
Son of a...
I didn't say it.
Okay, but you don't need to make the comments. So you want to see what multiplies to get 21. Okay, multiplies to get 21, but adds to get negative 10. Okay, so two numbers that multiply together to make 21, but add.
Negative 3, negative 7.
Yes. So we have negative 7 and negative 3. If I multiply those two together, I get 21. If I add them together, I get negative 10. So to factor over here, we have s minus 7 times s minus 3. And that would be your factored form for number 3. Number 4, I have s squared minus 16. So this is similar to what I had here. We're at x squared minus 9. So I have a perfect square with s squared and a perfect square with 16 and subtraction between. So this can factor to s plus 4, s minus 4. Okay, and if you don't think that that's the correct answer, you can always FOIL it out and see if you get what you originally had. Yeah.
So if it was positive, it would just be s plus 4.
If it was positive, so there's addition between them, you wouldn't be able to factor it.
Oh.
It would already be completely factored. You can't do anything with it. Okay, then number 5. Again, 5 is kind of like 3. We're going to do this x method. Okay, what multiplies to get that last number there, so negative 12, but adds to get positive 4. Think about it.
Huh?
Multiplies to get negative 12, adds to get positive 4.
Negative 2.
And?
Negative 2. 6 and negative 2.
I think you said negative 2.
Okay, so 6 and negative 2, multiply to get negative 12, and add to get 4. So here we have x plus 6 times x minus 2. And that would be your factored form for number 5. Okay, so you will have to factor like this as we go through our examples in simplifying these rational expressions. So a ratio of 2 polynomial expressions, such as 1,700 over d minus 33, is called a rational expression because it's a fraction. Okay, so you have a fraction with variables in your denominator. Because variables in algebra often represent real numbers, operations with rational numbers and rational expressions are similar. Just as with reducing fractions, to simplify a rational expression, you divide the numerator and denominator by their greatest common factor. So, example on the left there is if you had your normal fraction 8 over 12 and you wanted to reduce it. Okay, you could divide both by 4 and reduce it to 2/3. Okay, so 8 is 2 times 4, 12 is 3 times 4. Your 4's cancel out, and you're left with 2/3. You can do the same thing with your variables. So if I were to factor this numerator, I'd get x minus 3 times x minus 1. The denominator, you'd get x minus 5 times x minus 1. Now, since both the numerator and the denominator both have that x minus 1, those cancel out, and you're left with x minus 3 over x minus 5. So we can simplify this fraction just like we do any other fraction. So going through some examples here. Okay, we want to simplify each expression and then state under what conditions is the expression undefined. Okay, undefined meaning your denominator cannot equal 0. Okay? Your denominator cannot be 0. That makes it undefined. So here first, that numerator is already factored for you, so it's going to stay the same. Your denominator, however, I have this y squared minus y minus 6. That part can still be factored. Okay? So just like we did at the top, you can do that x method to factor it. Okay? So down here, my number that goes on top is at negative 6. On the bottom, I have negative 1. Okay, so what multiplies to get negative 6 but adds to get negative 1? Negative 3 and 2. Okay, since we are reducing these, it does help if you look at the numerator, because something in your numerator is going to cancel with something in your denominator. So if there's a minus 3 and a plus 4, well, I know 3 can go into 6, so one of these terms will probably be negative 3. Okay, so rewriting this, I have 4y times y minus 3 times y plus 4 as my numerator. Then in my denominator, I still have that y out front. And then I factored this part with a negative 3 and a 2. So I'll have y minus 3 and y plus 2. Okay, now that I've factored that denominator, I want to see where it's undefined. Okay, before I start canceling things, I'm going to see where it's undefined. So I'm going to set each of those parts in the denominator equal to 0. Okay, because I don't want it to be 0. So if I set y equal to 0, it's 0, right? That means y cannot equal 0. Okay, I have to do that with y minus 3 as well. So y minus 3 cannot equal 0, and I'll solve for y. So I add 3 to both sides, so y cannot equal 3. Last one is y plus 2 cannot equal 0. Subtract 2, and y cannot equal negative 2. Okay, so this is finding where it's undefined, because if I were to plug in negative 2 for y in any of those, on the bottom here, I get 0. And then I have 0 times whatever number this is, whatever number that is. And that's still 0. And your denominator cannot equal 0. Okay, that's why I have to do that part. Now, I can start canceling out like terms. So right off the bat here, I have a y over a y. Okay? Those are going to cancel to a 1. I also have y minus 3 over y minus 3. Those will also cancel. Okay? I don't have any more like terms. So I'm left with this 4 times y plus 4 over y plus 2. Okay? And off to the side, or next to it, we can write where y cannot equal negative 2, 0, or 3.
And that's necessary.
That's it.
But we need to say what x can equal
Yeah.
on the answer.
Okay, so that variable cannot equal those 3 numbers. Questions on that first one? All right, second one here. So we have our denominator all factored out already. Okay, we need to see where that can't equal 0. Okay, so where z cannot equal 0. So I'm going to set each of these equal to 0 and solve. So I have z minus 1 cannot equal 0. When I solve for z cannot equal 1. Okay? I have z plus 5 cannot equal 0. So z cannot equal negative 5. And z minus 2 cannot equal 0. So z cannot equal 2. Okay, so those are your 3 numbers that z cannot equal. Okay, so now what I want to do is factor if I'm able to factor. So I still have this z squared plus 2z minus 8 in the numerator, and I can factor that. Okay? So again, if you need to use your x method, your last number goes on top. That's negative 8. Your middle number goes on the bottom. So what multiplies to negative 8 and adds to 2? 4 and negative 2. Okay, so now I can rewrite that numerator. So we have 2z times z plus 5 times what I just factored. So I'll have z plus 4 times z minus 2. Okay, and that's over that denominator that was already factored for us. So we have z minus 1 times z plus 5 times z minus 2. Okay, so from this point, I can now cancel out like terms. Okay, I have a z plus 5 and a z plus 5. Okay, those two will cancel out. I also have a z minus 2 and a z minus 2. So those cancel. I can't cancel out anything else. So rewriting this, we have 2z times z plus 4 over z minus 1. Okay, and then z cannot equal negative 5, 1, or 2. Okay, and that would be your simplified expression. Okay, questions on that second example there? No questions?
I hope not.
What did she hear?
All right, on the back, example 2, we want to find for what values is the following rational expression undefined. So what do you think we're going to have to do to find those values? What do we do on the front? Okay, you're going to factor. What are you going to factor? Not everything.
The 8 and the, no, the 10 and 12. I don't know.
When I say undefined, okay? Shh. Hey, quiet. When I say undefined, that means where the denominator is equal to 0. So if you get a question like this, you're just going to take, shh, we're paying attention now, please. You're just going to take the denominator, set it equal to 0, and solve for those variables. Okay, so we're going to take this entire denominator here. Yep, so I have negative 6 times x squared minus 3x minus 10 equal to 0. Because we don't want that denominator equal to 0. That's what we're doing on the front. Now if I were to divide both sides by negative 6, right? They cancel here and I'd be left with x squared minus 3x minus 10. And 0 divided by negative 6 is 0. Okay, now at this point you want to factor. Okay, so we want to factor this. So you can use the x method. If you don't need to use the x method, don't use the x method. The number on top is negative 10. Bottom is negative 3. So two numbers that multiply to get negative 10 and add to get negative 3. Negative 5 and 2. Okay, so factoring this then, I have x minus 5 and x plus 2 equals 0. Okay, now I can set both of those quantities equal to 0. So we can set x minus 5 equal to 0 and x plus 2 equal to 0. Okay, solving for x will equal 5, x will equal negative 2. Okay, so the values where this is undefined is x is equal to 5 and negative 2. Yes.
I like that. That was real quick.
All right, example 3 is similar to what we did on the front. Okay, we're factoring and then simplifying. Okay, except for these two, there's a slight twist. Okay, so we want to factor what we can. So looking at the numerator, I'm going to look for terms that both of those numbers have in common. So they both have a z, right? Okay, so I can factor out a z in the numerator. And then I'm left with x minus 4 in those parentheses. Okay, that's over z squared times 4 minus x. Now, that x minus 4 and that 4 minus x are similar, right? They're kind of similar. But you can't just cancel them out, okay? Because in the numerator, the 4 is negative. In the denominator, the x is negative. Okay, so what we're going to do is in this numerator here, we're going to factor out a negative 1. Okay, so if I take out a negative 1, I have negative 1 times z. Now if I took out negative 1 from this x, what would that make that? Negative x. If I took out negative 1 from this negative 4, no, plus 4. I'm factoring out. Not adding or subtracting. I'm taking out a negative 1. So if I were to multiply negative 1 back into those parentheses, you would distribute it. Negative 1 times negative x is x. Negative 1 times positive 4 is negative 4. Okay, so I just pulled out that negative 1, and it changes the signs of both of those terms. Okay, so it changes the sign of both of those terms. Okay, and then this is still over z squared times 4 minus x.
Dang. So we can cross that over.
So now, since you have a negative x plus 4, that's the same as 4 minus x.
Cancel those out.
Okay, so those cancel.
Negative 1z over z squared.
Okay, so I have negative 1z over z squared. I can still cancel out a z, can't I?
Josh.
Yes. So I still have negative 1 over z. Okay, and that would be your final answer.
So,
Just the dugout, and it's like, no.
Okay, questions on what I did here?
Do you want to watch TV?
All right, letter B. Quiet, please. Letter B is the same process as letter A. Okay, we want to factor. Okay, that numerator we want to pull out like terms. So both of those terms have an A and a B, right? So I can take out AB. What's left then? I still have a B for this term,
Minus 5.
and then a minus 5. Now that's over 5 plus B times 5 minus B. And again, just like in letter A, I have a B minus 5 and a 5 minus B. Okay, so those don't cancel quite yet.
What? Oh, yeah.
You
this
need
is
to
backwards.
factor out a negative 1.
Yeah.
Okay, because you want to change the sign on both of those terms. So I have negative 1, AB. Then factoring out that negative 1 changes the sign on both of those terms in that parenthesis there. So I'll have negative B plus 5. That's still over 5 plus B times 5 minus B. So now, in the numerator, I have negative B plus 5, and in the denominator, I have 5 minus B. If you need to, you can switch that order, so I'd have 5 minus B, okay? If you need to do that so you can see it, that's fine. Otherwise, those two will cancel out. And I'm left with negative AB over 5 plus B. And if you keep the 1 there, that's fine. You can keep the 1 there. Okay, questions on factoring and then reducing?